A faint hum rolls through the factory floor as a worker wipes metallic dust from his gloves. He glances toward the long row of machines, each one shaping metal with steady precision. "Here," he says softly, "we take cold, unremarkable metal stock and guide it toward the form it was always meant to become. Every piece has a purpose. Every cut has a reason." His voice blends with the rhythm of steel and motion, then fades. Step inside the heart of an industrial environment rarely seen by the public. And nothing moves forward until it satisfies the strict demands of reliability, tolerance, and consistency. This is not simply a factory. It is a controlled ecosystem where materials, machines, and skill converge in a constant cycle of creation and refinement. At first glance, the facility seems timeless rows of automated machining centers, the glow of molten metal, pallets of steel bars stacked like building blocks of a future not yet assembled. But the story of this place stretches far beyond a single production run. The M4 platform, developed through decades of research and engineering, stands as a symbol of evolving mechanical design. Its components may appear small, but each one carries a legacy of industrial precision and continuous refinement. Manufacturing them requires not only advanced technology, but also a culture dedicated to consistent standards and an uncompromising approach to engineering challenges. In this environment, everything begins with materials, long before a single component takes shape. The factory receives shipments of metal stock steel alloys selected for durability, structural integrity, and resistance to stress. Bars and billets arrive in uniform stacks, each marked with heat numbers and material origins. Before they ever approach a machine, the materials undergo verification, chemical composition checks, hardness evaluations, and surface inspections. This early stage ensures that the foundation of every future part is trustworthy. Once validated, the metal moves deeper into the process. The first transformation happens in the cutting area, where automated saws reduce the stock to precise lengths. The cut pieces slide onto conveyors, heading toward their next stage. Nothing here is rushed. Even this simple reduction of raw stock is monitored by sensors to maintain uniformity. The trimmed blocks and rods now resemble the early seeds of future components still undefined, still far from their final role, but already entering the controlled rhythm of production. Next comes the shaping phase. Forging presses apply immense force, compressing metal into strong, dense forms. This step gives durability to components that require reinforced structure. Heated billets are pressed into dies, emerging with rough outlines of future housings, carriers, and extension parts. The metal cools slowly, stabilizing its internal structure and preparing for the precise machining work ahead. This is a cinematic appreciation of how shaping metal through pressure strengthens it, guiding it toward dependable form. From forging, the parts advance into machining bays, where the environment changes. Here the noise becomes sharper, more focused. Rows of CNC machines operate in choreographed movements. Coolant mists drift through the air as cutting tools carve away steel with microscopic accuracy. Clamps tighten, spindles spin, and robotic arms transfer parts from one workstation to another. These machines do not guess. They follow digital models, ensuring that every cut aligns with the platform's rigid dimensional requirements. One machine brings a part into existence by carving internal pathways. Another focuses on exterior surfaces, ensuring smooth planes and precise ready. Threading units form the meticulous patterns needed for secure attachments. Across the bay, quality technicians monitor live readouts, comparing each dimension to digital models. A difference of tenths of a millimeter can determine whether a part proceeds or is redirected for correction. Even within this technical atmosphere, there is room for human expertise. Operators listen for subtle changes in pitch, indicating tool wear. They feel slight temperature differences in newly machined surfaces. They inspect edges under bright task lights, searching for irregularities invisible to automated sensors. Machines maintain precision, but humans safeguard consistency across every cycle. As parts take shape, they move toward the finishing line. Here surfaces are smoothed, burrs removed, and edges refined. Tumbling machines polished smaller components. Larger parts undergo controlled surface treatments, designed to strengthen them against corrosion and friction. The environment is quieter here. The aggressive sounds of machining give way to the soft vibrations of surface finishing equipment. It is a final refinement phase, making each piece ready for integration. Then comes assembly, a coordinated sequence where components converge. Conveyors carry parts from machining cells to assembly stations. Technicians fit pieces together using calibrated fixtures that maintain alignment. At one station, housings meet their internal structures. At another, small, precision-machined elements integrate into larger modules. Everything is guided by detailed manufacturing plans that emphasize consistency and compatibility. The assembly line is not a place of improvisation. It is controlled, measured, and deliberate. Workers perform visual inspections as each component joins another. Digital torque tools ensure the connections meet correct tension levels. Sensors confirm alignments before the parts progress to their next stage. The closer the components come to their final form, the more intense the scrutiny becomes. Each component undergoes evaluations designed to confirm structural integrity and functional reliability. Stress frames apply pressure to critical points, simulating real-world strain. Alignment tools verify that geometries remain true after integration. Any piece showing irregularities is removed from the flow for further analysis. It ensures that the components reaching the final storage bays meet the highest engineering expectations. Once components pass inspection, they move to the logistics area. Here they are organized into crates, trays, and sealed containers. Labels identify production batch, test results, and destination. The finished parts await distribution to assembly plants or authorized partners, responsible for integrating them into full systems. This is where the journey of each component ends, on pallets lined with carefully machined shapes that once existed only as cold metal stock. Now they reflect the accumulated work of engineers, machinists, technicians, analysts, and inspectors. Each piece holds a story of pressures endured, measurements achieved, and standards met. They leave the factory not as isolated fragments, but as essential building blocks of a larger mechanical architecture. If you look closely at the finished components arranged in the final bay, you can trace the echoes of their creation. The solid grain of forged steel, the immaculate precision of CNC machine, the subtle finish left by polycine, the uniformity of dimensions born from rigorous inspection. These marks tell a story of industrial refinement of a process where every stage is guided by purpose and accuracy. The factory hums steadily as another batch of raw metal arrives at the loading dock. The cycle begins again. Steel becomes shape. Shape becomes form. Form becomes component. And through this constant transformation, the facility continues its mission, turning unremarkable metal stock into the final components of a platform known for its engineered dependability. In the end, the finished pieces stand not as symbols of conflict, but as achievements of controlled manufacturing and industrial discipline. Their creation reflects the depth of human ingenuity and the precision of modern engineering. Here, in this facility, the journey from raw material to refined component unfolds with unwavering consistency. From the first spark of metal cutting to the final inspection tag, every part of the process serves a single purpose: creating dependable components through disciplined industrial production. And as the last crate is sealed and marked for shipment, the factory settles into its steady rhythm once more, preparing for the next cycle of transformation that begins with nothing more than a bar of metal waiting to become something greater. Thanks for watching. If you found this look inside the world of precision manufacturing interesting, be sure to like this video and subscribe for more content that explores the fascinating intersection of technology and engineering. We'll see you in the next one.